Yeah. Today topic is DFA and NDFA. What is DFA? DFA is deterministic finite automata. Here deterministic means we can say clearly that from some state to moving from one state to another state, definitely it moves to one state. Any transaction by taking some alphabet as an input and moving to the some state, whether it moves to the some q1 or q2 or q3. In the set of q's only itself it will moves to the some state. Here, by considering the q naught, by considering the q naught, by taking some input alphabet a, it moves to the some state, that is x1, or it moves to the x2. Then we can say that it is a deterministic finite automata. That is, clearly we can say that from q naught to q1 or q naught to q2, it is moving by the input value a, is called the deterministic automata. How it is going to be defined in a mathematical way? DFA defines as a machine M. M contains the five tuples or a components. It's set of five tuples. That is Q, comma, sigma, comma, delta, comma, Q naught, comma, F. Here the capital Q indicates or represents non-empty set of states. That is, the Q must contain some states. Sigma represents the input alphabet, that is A, B, C, or 0, comma 1, or special characters will be defined as a input alphabets. Coming to the delta, delta maps from, that is transaction. Delta is indicated transactions. That is moving from one state to another state is called a transaction. So delta maps Q into sigma tends to Q. Here we are saying that capital Q contains some set of states, right? At one state, by considering the input alphabet, that is, it is reading the input alphabet and moving to the some state which is available in the capital Q. So we are representing that Q into sigma tends to Q. Next, Q naught is an initial state. F is an final state. So these are the representations of the finite automata. It is a phi tuple. It contains the Q, sigma, delta indicates the transitions, Q naught, and F. Now we will see the example and how the transaction state to machine, how it is going to be mapping. Mapping of transition diagram to machine. Machine indicates that phi tuples. So here we have some state Q naught and Q1. Between that we have a connection, that is it is moving from q0 to q1 by taking the input alphabet a, that is called the transition, that is delta. For the delta, q0 on input alphabet a, it is moving to the state q1, it defines the transition. In the same way, q1 to, by reading input b, it is moving to the state q2. This is the way it is going to be mapping to the machine. But here we can say that q contains, the machine m contains the five tuples. The first one is q. The q equal to, here how many states we are having? Here we are having the three states, that is q naught, q1, q2. So q equal to q naught, q1, q2. Next one is sigma or summation. Summation is indicates that, yeah, input alphabet. Here we have the input alphabets are a comma b. So input alphabet is a comma b. Now we have to write the delta. Delta maps from q into sigma tends to q. That is, q is the starting state which is there in the Q, capital Q. So first one state is Q naught. So Q naught, here it is a sigma. Sigma is just pointing to the A, pointing to the A. That is reading the A as an input and moving to the state Q1. Q is available in capital Q. Q1 is available in capital Q. So that we are saying that Q into sigma tends to Q. So the Q, the initial state Q naught or starting state Q naught is available in the capital Q. Sigma is taken from the delta, that is A, and Q, we are getting the output Q, which is available in the set of states. The same way for the Q1 also. Q1 on B moving to the state Q2. Here we are not defining the, in this diagram there is a no starting state. Why means the starting state indicates some arrow mark with the start, with start. Here we are not having the arrow mark with the start, and so we're keeping that as a question mark here. And final state, in the final state should be identified by the double double circle. The state should be having the double circle. So here we are not identifying any final state, so question mark. Let us see the in another example. Here same thing. Here we have the start symbol, so we will get the initial state is q naught, and another state we have the q3 as a final state. Here we have the transaction from Q2. There is a no connection. That is, no connection between the Q2 and Q3. So we need some connection. So with the input A, it is moving to the state to Q3. So the finally we are having the totally four states. The Q will be updated to 3 to 4 states. Sigma will be updated. Here we have the A. Already A is existing. So no need of repeating the A multiple times. So single time we are going to be representing as an input. A comma B itself is an input alphabet. Here we have to update the transition states. And here we have to update the initial state and final state. Let us see what the final mission will be the. So the final mission will be the Q equal to Q naught comma Q2 comma Q3 summation equal to a comma b, delta naught into a tends to q1, q1 tends to b, sorry, q1 into b tends to q2, q2 into a tends to q3. But we are not considering the q3. Why means q3 is not having any transitions. There is no transition from the for the q3, so we are not taking. If you are considering, means the q3 equal to 5, q3 equal to 5. So initial state is q naught. Here we have the starting symbol q3. Here we have the double circle for the q3. So final state will be the q3. Now coming to the NFA. Here in this NFA, we can say that here we have the state some Q naught with input A. It is moving to the state either to Q1 or Q2 or Q3. That means from the one state by considering the single input alphabet A, it will move to the A, Q1, Q2 and Q3. So here we are not deterministically we're saying that it will go to the Q1. No, it will go to the Q1, Q2 and Q3. More than two states, one state, it is going to be moving. So it is called the non-deterministic finite automata. How the machine will be defined? M is a five tuples. That is a five set of tuples. First one is capital Q, sigma, delta, Q naught, and F. The same as a DFA. The notations are the same as a DFA. Q is a non-empty set of states. Sigma is an input alphabet. Here the change is in the transition. Delta is a transition. Q into sigma tends to power set of Q or to power Q. Y means it is not moving to the single state. It is moving to the multiple states. That means at the Q at one state, considering the input alphabet and moving to the multiple states. So it is a 2 power Q. Q naught is an initial state and F is a final state. Now we will see the example for the NDFA. Here we have the transition diagram. That it is called the transition diagram. Here totally we are having the four states Q0, Q1, Q2 and Q3. And we have the alphabets are A and B. That is A is repeated multiple times and B is repeated multiple times, but we will consider as A and B only. Now coming to the transactions. Coming to the transactions. Here consider the first one Q1. Consider the first one Q naught on input symbol A moving to the state Q1. Right, moving to the state Q1. That is this transaction 1. The same way with the same input A, here also we are having, and it is moving to the state Q2. So we are getting that Q naught on the input A, it is moving to the states Q1 and Q2. So we are going to writing in a square basis Q1 comma Q2. After completion of Q1, it is moving to the state Q1. So in the Q1 state, it is going to be read in the B as an input. B as an input and moving to the Q2 and Q3. So here we wrote the Q2 comma Q3. Here we have the Q3, Q2 also. So state Q2, it is going to be read in the A. Only the single state is going to, that is Q3. On A, it is going to the Q3. On B, it is going to the itself, looping itself. That is moving to the Q2 only. Initial state is Q naught, final state is Q3. Let's see the let us see the final output what we are getting. The machine M. So here we are going to be updating the states, transition states. Here we have the Q naught, Q1, Q2, Q2 with A, Q2 with B. Q2 with 3, we are not considering. There is a no transitions for the Q3. Right? So we can write that Q3 equal to 5. That is no transitions available. So this is about the NFA and DFA.